Alright, this is the video for lesson 1.8 inverse functions. The assignment is page 231, 12 through 26 even. Alright, basic characteristics of inverse functions are that inverse functions are a pair of functions. It's like your left shoe and your right shoe. They kind of naturally go together. Two inverse functions, for example, would have points that are exactly opposite of one another. So, for example, if one function had the point where the x value is 2 and the y value is 10, then in the inverse of that function, you would have the point 10, 2. Basically, two functions are inverses if they reflect across a diagonal line that crosses through the coordinate grid like this. Here's the diagonal line I'm talking about. It's the line y equals 1x. This has a slope of 1, and it goes through the origin, as you can see. Okay, so this line right here, if you reflect a graph across that, you get the inverse of a graph. So here's f of x is x cubed plus 2, right there. If you reflect that graph across that line, and sometimes I like to align that line vertically, you can see that if I reflect this across that line, boom, I get that right here. So this graph that I'm drawing right now is the inverse of that first curve that I drew. So basically they're just reflections. And their x's and y's interchange. The x's on this graph become the y's on that graph. The y's on this graph become the x's on that graph. Now, to show that they are inverses, all you basically have to do is substitute one of the graphs into the other graph. So here's what it looks like when I write it down. We're going to find f of g. So I'm going to take the function f, which is x cubed plus 2. And instead of putting an x here, I'm going to take the x out, and I'm going to put the entire function g in that position. So the function g is the cube root of x minus 2. All right, you can see that when I do that, I have a cube root and I have a cube. Those two elements will cancel, and I'll simply get x minus 2 left over, and then the plus 2 over here. The negative 2 and the positive 2, when you add them together, cancel, and you get x. So if you get a result of x, then you have shown that they are inverses. That's what I wanted to prove that. Here's another example. If I want to find, oh, and by the way, you can take g and put it into f like we did, or you could take f and put it into g. Substituting one entire function into the other function, you should get an x either way. So it doesn't really matter which one you do. I always like to find f of g. The book is set up so that it's easier to do it that way, so that's what I'm going to do. All right, we're going to show that they're inverses, so I'm going to substitute one of the functions into the other function, and then I'm going to simplify, and if I get just x left over, then I've shown it. 4x minus 7 is your function f. So I'm going to take out the x here, and I put in the entire function of g, which is this fraction here, x plus 7 quantity divided by 4. So what happens first is the 4's are going to cancel, and I just get x plus 7, and plus 7 minus 7 equals x. Sure enough, I have shown that they are inverses. Here's another example. All right, now this time we don't want to show that they're inverses, we want to find the inverse. So basically what you do is you start with, or at least what I start with, is I take f of x and I write it as y instead of f of x, because they're pretty much the same thing. And then, step 2, I interchange x and y. So instead of y equals 2x plus 7, I get x equals 2y plus 7. Now I solve for y. So if I want to get y on the left and x on the right, I'm just going to switch this entire thing. You can do that. You can take the entire left side of an equation and change it with the entire left side of an equation. So I just put the 2y plus 7 on one side and the x on the other side. Then I solve for y. So I'm going to subtract 7 on both sides. So I get 2y equals x minus 7. And then if I divide both sides by 2, I get that. This could also be written as y equals x over 2 minus 7 over 2. So the inverse of the function f is written like this. It's written with a little -1 up here. It's not an exponent, it's just an indication of inverse, is x over 2 minus 7 over 2. Or you could write it like x minus 7 over 2. Okay, so we're going to find the inverses 2 more times here. Just a couple more examples. So, step 1, replace the f of x with y. Step 2, exchange the variables x and y. Step 3, solve for y. I'm going to change everything around. And then solve for y by adding 1 first. Dividing by 4 on both sides. And then I have y cubed, so I'm going to have to take the cube root of both sides. We do not need a plus or minus here. So I get y equals the cube root of x plus 1 over 4. So f inverse equals the cube root of the entire quantity x plus 1 over 4. One last example. Again, you start by replacing f of x with just y. Then I'm going to exchange the values of x and y. Then I'm going to rewrite everything on the other side to get the y on the left. I'm going to add 1 on both sides. And then what do? Well, I have a y on the bottom here. What I'm going to do here is I'm going to multiply by y on both sides. So I'm going to say y times 3 over y and y times x plus 1. You could also cross multiply this if you want to think of x plus 1 being over 1. It gets you the same result. Alright, now, what do I do here? Well, I want to get the y by itself, so I'm going to divide both sides by x plus 1. Okay, so I get y equals 3 over x plus 1. So, that's my answer. F inverse of x equals this, 3 over x plus 1.